Okay, good afternoon, everyone. Thank you so much for the introduction. Can you see my slide screen all right? Wayne, if you can just let me know that you can see it and hear me just fine.
I can hear you just fine, and I can see the slides.
Wonderful. Okay, well, I appreciate the invitation to present this afternoon. This topic is near and dear to me. As Wayne mentioned, I'm with the Portland Cement Association. However, in a previous life, I was an inspector and spent many hours outside staring at defects in concrete. And I think this topic comes up often in our industry when something isn't suitable to an owner. People get callbacks. So as I understand, we have a wide variety of participants today, designers and specifiers, as well as constructors and producers. So I'd like to get to this topic from the specifics of why surface defects occur, what we can do to prevent them in the future with some choices in our material selection and finishing requirements and specifications. And then also, depending on the topic, I might get into a little bit on methods of repair. So with that said, why do surface defects occur? That's a common question. I don't think concrete gets a fair rap. We can make it turn out. But commonly you will see surface defects such as scale. You might see some imperfections in uniformity, such as consolidation, or depending on the surface life, you may see a variety of issues such as corrosion and scale that you see on the far right. So why do these occur? If we were in person, I'd be asking you this, but since you're through a computer, I can't see you. What I want to know, depending on where you come from, is who you typically blame. Because this shouldn't be a blaming game. This should be an understanding of the process of concrete from the beginning of the material selection to the end of the construction. And when I see all of these, I do see how people could potentially blame a finisher for many of these issues. From scaling, you might think that they added additional water to the mixture, increasing the water cement ratio to something that's not suitable. You might think that they added salt too early in the concrete's lifespan, which a homeowner or even a commercial owner does that for safety issues. So we need to design our concrete to be able to withstand scale resistance or give them a preferred method of thawing and being able to safely use that surface. When you see uniformity issues, you might think that the contractor did not properly consolidate the concrete, but it could be due to the mix design itself. And when you see a corrosion issue, you might think that the contractor inappropriately placed the reinforcing steel and it didn't have adequate cover. But when I look at all three of these, I can easily see these being a specification issue. So I think in our industry, it's very important that we don't just blame a contractor for surface defects. Surface defects occur because concrete was inappropriately maintained in the field, or it might have been inappropriately designed. So when I look at this scale, the spec itself might not have had a high enough bar in the minimum design requirements to be able to handle freeze thaw. When I see the consolidation issue, I wonder if you qualified the mixture by a maximum slump, thinking that that determines its quality and therefore had really just made placement issues for the contractor. And when I look at the corrosion, I want to know what type of maintenance was on this structure, what type of serviceability plan they had, and what type of repair plan was part of that specification as well. So the other topic that we do need to discuss is not just why issues occur, but being able to properly identify problems. So this topic is slightly negative with the term defect, but really often these aren't defects. Sometimes they're just blemishes, and there is a significant difference between a blemish and a defect. I have a gorgeous 2,700 square foot driveway made of exposed aggregate concrete, and it is full of blemishes. And especially for someone in our industry who has a high standard of concrete, you know what? It's a gorgeous driveway. The majority of My family and neighbors cannot see the blemishes because the imperfections are well hidden with the textured surface. But it has everything from a piece of wood in it to some drying shrinkage cracking to some staining due to iron ore in the aggregate. It has all of these issues, but to me, those are all blemishes because the product itself is gorgeous and it is serving itself well, and the drying shrinkage cracks are maintained in the proper location. So it is important to be able to identify symptoms, know why they occurred, and if it is a problem for you, but also to determine if it's going to cause further distress and deterioration in your structure. So band-aiding a blemish may cause further deterioration, or it might be the suitable solution for you if it's only an aesthetic issue. So depending on what team you play for, if you're the designer, or if you're a material supplier, or if you design the mixture yourself, or if you're the contractor placing the mixture, you all play a part in making the concrete turn out. And I know George Siegebrecht spoke last week, but this is one of our favorite triangles. We believe that if you remove any of these, if you remove the quality of the design, if you remove the quality of the workmanship, you're not going to get the product that you wanted or were thinking you might. But really, the other thing that needs to be considered in all of these circumstances is the environment you're placing it in. And that means not just a freeze-thaw environment or a sulfate environment, maybe you have some reactive aggregates, all the things that you might need to consider. It's also, is it a hot weather placement or is it a cold weather placement? Those things change how the concrete will perform in its fresh properties, and those change how you should design the mixture for that placement. So my goal in a non-pandemic world, as I was mentioning to the organizers, is for you all to get up and hug. You all play a role in getting the concrete to turn out, and you all have certain expectations of what the concrete should be. So mock-ups can solve that. Making sure your specifications are current can solve that, but also really identifying what your expectations of aesthetics and quality are, and durability, of course. So there are a lot of great references out there. I'm going to really get into the actual defects this afternoon, but I would encourage you to pick up some reference guides. These are not standards, these are guides. So ACI 201, the Durability Committee of American Concrete Institute, has a condition survey that I highly recommend for you. Also PCA, our company, has an information sheet on concrete surface defects. I'll be happy to share that with the group with my slides after the program. And then another thing, if you're paying your taxes, that I highly encourage you as designers to be well aware of the mechanisms behind these symptoms, is a product from the Corps of Engineers. This evaluation and repair guide has been around since the 50s and was well updated in the 80s, and I'm aware of how old I'm sounding, but concrete hasn't changed that much. We've already known these symptoms since we've been placing it in large volumes through the 50s, and we can properly identify a defect, and we can properly identify a suitable method of repair. What has changed is the materials we're using. What has changed is there are more rapid methods of repair that may be appropriate for certain applications, and then sometimes the good old-fashioned route and seal and all those do apply. So this repair guide, I highly encourage you to download. You just look it up by its title. They're called engineering manuals. So just go to the Corps of Engineers and get that information. I'd be happy to send you the link if you can't find it. All right, let's get into the meat of the program. So I'm going to cover the defects with mostly pictures and a short definition of each of these so that we don't accidentally call a bug hole a pop out or anything like that. But then I'm going to get into why they occur and what we can do about it in the future. So on the cracking front, there's a debate if cracking is really a defect. In my opinion, it's not. You get jokes in our industry that there's 3 certainties in life and there's a crack in every ready-mix truck. Sure, just tell it where to go. And there are different types of cracks. There is not just one type of crack in our industry and one reason why it formed. So I think it's very important that we understand patterns of cracks. There's a difference between an isolated crack and a ones that are mat cracks, whether they're traverse to a joint, whether they're longitudinal, if they have, if they're isolated, if they have feathered edges, if they're through cracks. All those things tell you a story about how the concrete is feeling. And the concrete definitely has some strong feelings about cracking if it's in the wrong location. So on the non-structural side, which is what we're going to focus on today, this isn't about overloading a structure or having any issues with any type of disaster, such as an earthquake. This is about after finishing and typical properties of concrete that can cause cracking. If you're not careful in the plastic manner of concrete, you can get what is known as plastic shrinkage cracking. And these are relatively short cracks. They can be longer, but they're varied lengths and they're typically parallel to one another. They can be inches apart or several feet apart, depending on how that concrete felt as the tension built up. But plastic shrinkage cracking forms as it sounds. It forms in the plastic concrete as you're finishing it. And it means that there was rapid surface evaporation. And just as it sounds, the concrete tears. So what you would see is a tear pattern on the surface. And this is before, usually typically when you're in your final finishing operations is when you might see it. If you see plastic shrinkage cracking and you're finishing the concrete, there are some guides out there that would encourage you to close that crack back up by finishing over it. There's some old manuals out there that might encourage you to strike both sides to close it together. The problem is the crack is not usually shallow. Plastic shrinkage cracking on its own is a durability problem if there is reinforcement in the concrete. And the reason being is we don't know how far down these cracks went and how wide they might get. So it depends on the crack itself. My answer to all troubleshooting is it depends. And it depends on where they're located and if there's steel in that structure. So if it's a driveway and there's plastic shrinkage cracking, to be honest, it's not a serviceability issue. If it's an interior floor slab with dowels, it's also not a serviceability issue except for maintenance when mopping and such. However, if it's a parking garage or a bridge deck and you have through cracks, then it's definitely a serviceability issue and a durability issue. And whether or not you should seal these cracks depends on how you're using that structure. So for repair, yes, you can seal these cracks. There's lots of cementitious grout. There's lots of other types. If it's a surface that gets wet and dry and you're worried about being able to bond, cementitious product is most appealing. If it's in a dry status full time, then you can consider some of these urethane types of sealants. The choice between a cementitious ingredient and an epoxy ingredient is always up for debate, but my theory, and it's just my opinion, is anytime you can use like with like, they're going to be more compatible thermally. So if you can use a cementitious ingredient and get it in, depending on how thin that crack is, it's highly encouraged. But again, there's shrinkage that comes with these products as well as epoxy products. So lots of guidance out there on crack injection. The most popular crack out there besides a plastic shrinkage crack would be a drying shrinkage crack. It's what it sounds like as well. When concrete is placed, it's at its largest with exception of creep from strain. If you have elastic load that causes creep, you might get some deflection and sustained change in the shape of the concrete. But in general, all things considered, concrete has more water in it after you place it, and that was water of convenience, we call it, for finishing. And as it dries, it's going to shrink to its center of mass. So depending on what shape you've designed it for, unless it's a circle orbiting in space, it is restrained in some way. It's going to be restrained on its subgrade. It's going to be restrained from the interior steel. It's going to be restrained against whatever you placed it against, whether it's adjacent concrete or another structure. And as it shrinks, it's building up stress and it's shrinking to its center of mass. What we want to do is relieve that stress. That's what the concrete wants to do as well. If you don't do anything, it will show you that it didn't enjoy how it was designed, and it will crack in what we call a typical three-prong crack that you see here, showing that it's shrinking to its center of mass and it's trying to relieve it. If you end up with a straight crack, that just means that somehow it had a relief plane. Maybe the stress buildup was really more settlement cracking because of reinforcing steel underneath. But what we also get for drawing shrinkage cracks when you're doing things correctly, if you tell concrete where to crack, it will dry shrink in the joint and activate that joint. So this is an excellent example in this image of a saw cut joint. Whether it's deep enough is up for debate. It might have been an early entry saw, but in this instance, it activated at the joint. That's what we want. That's how we design concrete. So one of my largest frustrations is cracks are normal, everything cracks. You can tell it where to crack, and you can design your jointing pattern to make some beautiful concrete. Yes, there are cracks in my driveway. The majority, 99% of them, are in the joints as designed, and I do have steel in my driveway. But what's important there is that I have the stoop that I know is restraining an edge, and I knew I was going to get a crack propagating from the corner of a stoop where I did have isolation, but it was so much weight and restraint that it cracked, but I had steel right up against within a couple inches. So the crack is tight and it's held together by the reinforcing steel. Steel doesn't stop concrete from cracking, it holds it tightly together. So it's up to us as to what is suitable for our design and what we can handle in construction. Another example of cracking that commonly occurs but can be overcome with the right type of construction is settlement cracking or subsidence cracking, where cracks form in the fresh concrete over an embedded item, typically reinforcing steel, but also pipes and other things that might be. And that's usually happens because concrete settles as it's placed and the bleed water comes to the surface. The bleed water is not needed in the concrete after you're used it for workability. It comes to the surface and we wait for that bleed water to evaporate during the finishing operations. But during that settlement, you may get some tension built up that can cause some cracking. With that said, we definitely want to reconsolidate over reinforcing while it's still in its fresh state. Make sure that's well consolidated at that stage. Just finishing over this type of tension, if you see it, I'm not sure that you'd actually see it till after the concrete's hardened. It will only cause the crack to be covered and it would still be open up underneath. So the prevention here is proper consolidation of flat work, which is often ignored in our industry. So we do need to consider how you're going to consolidate around steel. And then another instance of cracking that needs to be well defined is thermal cracking. And thermal cracks don't necessarily look different than drying shrinkage crack. They typically are a longitudinal crack and happen to be every 50 feet or 25 feet, depending on the thermal expansion of that concrete and what that coefficient of thermal expansion is in consideration to the temperature differential. So concrete naturally expands and contracts. We need to allow for room for that, and that's part of your design process. It's right there in the code. It's right there in the specifications. Rule of thumb for flat work is about every 50 to 100 feet, depending on the thickness of the structure. And unfortunately, there are examples of when this isn't done properly. So in this example, this joint was probably filled with debris. So if these joints have been maintained, then unfortunately on a very hot day, concrete's going to expand. If it doesn't have an area to relieve that expansion with an isolation joint, then and an expansion joint, then it's going to heave. In this example, a water pipe had also broken. So there was several examples of why that pavement heaved. In the picture on the right, it's a sidewalk. We don't give sidewalks enough credit. They're important to us. They also give our public their view of concrete. So we need to build them to a higher standard in our communities. But in this instance, the sidewalk did us a service. What happened here is there's a parking lot and it needed some expansion joints, but they didn't put them in. So when the concrete heated up, it expanded and it pushed, and that was several inches of expansion. And the sidewalk, being weaker than the pavement, was kind enough to relieve the stress by cracking and faulting. And if it hadn't been there, most likely that building's foundation wall would have felt that stress, which would have been a much bigger structural issue. So we can thank that sidewalk for putting in an expansion joint. However, what we really should do is put an expansion joint against the sidewalk that is wide enough, and then potentially put another expansion joint every 50 or 100 feet, depending on how big this parking lot is, and then redo the sidewalk to give it another go. But this does unfortunately happen in our industry when we don't design for expansion joints and when we don't design for thermal differences. The temperature differential, typically we want to design for cooling slowly so you don't get a temperature differential above 35 degrees Fahrenheit or 20 degrees Celsius in the interior of the concrete versus the exterior, like the vertical wall showed. All right, so that's 101 on cracking. There's a lot more I'd love to discuss, but I only have an hour with you here. So I wanted to spend some time on the defects. With that said, we want to properly identify these. And like I said, cracks aren't just cracks, they're isolated, they're patterned. There's lots of things to consider. But on the surface defect side, really we're needing to understand the nomenclature in our industry, which is why I encourage you to read ACI 201's guide, and if you need PCAs, it has the similar nomenclature, but we want to use the same terms and we want to understand what they mean. So I'm going to go through and describe all of these listed here and then talk about some repair strategies. So on this person's finger is some dust. Dusting is a fine powder of latenance that builds up on the surface of concrete at times. Reasons for dusting, there's a variety of reasons why this might occur. One reason might be that it rained on the surface or that there was a high water cement ratio on the surface. And one of the most popular reasons that happens is because people feel the need to bless their concrete. Depending on what type of mechanical finishing operations you have, you might be playing some sort of artari or adding water. There are finishing aids that are usable instead of adding water. Some of these finishing aids have up to 90% water in them. So it's important to leave the concrete alone if you're doing any type of monomolecular film and not finish it into the surface where you'd increase the water cement ratio at the surface. Any increase in water over a certain amount is going to make it more prone to dusting. So this is a big no-no. I know it happens, but it's not what we want. And another thing that can cause dusting, one of the most popular reasons, and I'm sure we're thinking about it as our temperatures go down, is the choice and selection of heaters for cold weather concreting construction. These heaters need to be vented for the worker's safety, for carbon monoxide poisoning, but they also need to be vented because the carbon dioxide, if it hits the surface of the concrete, will turn the concrete into chalk at the surface. This is also true for machinery. So for instance, on a small project where you might be driving the worker truck up to the edge to take the equipment out, and you might leave the truck on. If that exhaust from the truck hits the surface of fresh concrete, it can cause dusting. So that's another example. If you ever get dusting in certain areas and not in others, it could be due to irregular bleed as well. So if you have a high amount of bleed in concrete, that excess water comes to the surface and then you work it into the surface, that can also cause dusting. So now, is dusting a defect? I'd say it depends on the use of the structure. If this is an industrial floor slab, absolutely you have an issue here. I mean, this is going to cause a lot of issues as you're driving forklifts over the surface of the concrete and you're creating wear and tear on that surface. It's not an abrasion resistant concrete. If it's a basement slab, what's the final surface? What was the expectation of the owner? Were they going to put carpeting down? Then you're okay. Were they going to put tile down? Now we need to talk about bond quality. So what you need to do is remove the dusted layer down to the quality. And for how much it dusted, it would depend on what water cement ratio you raised it to, what happened to the surface as to how much concrete you need to remove. So yes, you can remove dusted. There are products out there that talk about you just applying a solution to the surface and that'll turn it into something similar to a sodium silicate hardener on the surface. The problem I have with that solution is the bond. As a person who used to work in the repair industry, I Feel strongly that you're not prepping the surface in a high enough advantage for bond. You'd basically be making a delaminated surface for the majority of these products. What you really want is to remove all of the dusted layer and then apply that sealer so that the dusting doesn't come back. Otherwise, it can come back. And again, it just depends on what the surface of that slab is. All right, another example would be blistering. Next to the hammer in the middle of the screen, you might see some irregular raising of a thin layer of the surface. So blisters can happen in concrete immediately after finishing. It implies that there's trapped air or water right under that surface layer, that top 1/8 inch or 1/4 inch of the surface. And trapped air or bleed water is a sign of a finishing timing issue. It means that the concrete mixture and the finishing operations were not timed well. So it could be the type of finishing too. You can seal the surface by using the wrong product, such as a steel trowel on air and train concrete. That's something that does happen. What you see here is a close-up section of concrete where you can see the blister in the middle of the screen here. What happens also, it can happen from just high bleed rate, where bleed water gets trapped under reinforcing steel as well, but also at the surface. If it happens on formed concrete, formwork concrete, those will tend to turn into the bug holes, and we'll talk about those in a couple slides. Is this a problem for you? A couple blisters on the surface of your concrete? You should know the answer by now. It depends. It depends on what your surface quality needs are. Truly, this is a blemish for most structures. However, if you need surface ride and abrasion resistance, then it is an issue. And one example would be the project shown here. This is an airfield where they had severe blistering on a runway. So my recommendation for repair of a blister where you can't deal with any loss of section of the surface, and an example might be FOD, the foreign object debris for an airfield. Otherwise, I'm thinking most structures can handle it. It's really about, for this instance, removing all of the blisters. So you can tell this is a government project because they're drilling every single hole and sweeping away the particles and then filling it with a cementitious grout. So that's a personnel thing. They were worried about leaving any debris on the surface, so they did them one by one. What they could have also done, especially in 2020, is they could have ground the surface and then swept the surface and made sure it was clean. And then whether or not they had the right tolerances, if you need to apply an overlay or just a sealer, it depends on where we're at with the surface quality. And actually removing that top layer, you might have sound quality concrete right beneath. It depends on the mixture and why the blisters occurred. Blisters sometimes come with other issues of trapped bleed water. Another example would be delaminations. Excuse me. Delaminations are when you have a fissure or a separation, basically a crack, right underneath the surface of your concrete. So under that top 1/4 inch or 1/8 inch, you now have a separation of that surface layer, just like I was talking about for repairing dusting. This unfortunately usually doesn't last. And after loading the structure, whether it's people, light and heavy, or it's cars, or it's forklifts, as you get the traffic, that layer will come off. And it may come off as a scale, it may come off as full sheets, and these are surface delaminations. This is very commonly done because you've sealed the surface, and this could be in combination with blisters. And that means in most concrete, it means that you've tilted the blade too tight, too quickly during floating operations instead of final finishing operations, and the bleed water hadn't all come out of the surface. So what can you do in that instance? Well, if you knew you'd sealed the surface too soon, which I'm not sure how you would know that because unless you saw blisters coming, is if it was fresh enough concrete, you could open the surface back up. And one way to open the surface back up is if you had a wood float. You could tear the surface and let it breathe and let that bleed water come out. That's if you had enough time to be able to fix that surface. Unfortunately, often we don't see these problems until after the concrete has hardened, and then it's a detection by non-destructive testing of a chain drag and other methods of soundness that would allow us to know that we had this issue. So are delaminations an issue for durability? Again, it depends. What's that structure being used for? If you remove that top surface, would you have quality concrete underneath? What are your tolerances on finish? Do you need an overlay? So again, it depends, but often delaminations can be from improper finishing techniques as well. We can not just seal the surface, we can overwork the surface as well. And if that happens and you get a bruised surface, what you're looking at here is a close-up of concrete section where the top half inch or quarter inch is bruised. So we need to remove that layer of deteriorated concrete down to an area that is in good standing. So one way we do that on vertical structures that have delaminations is we use bush hammers, but we like to use lower impact, because if you're just going to remove it with a hammer, you're probably bruising the surface. So then to put an overlay on it isn't necessarily going to bond to anything that you've beat the heck out of. So same concept with a surface slab. If you're going to do that, then you need to be able to remove it safely and keep the good quality concrete intact. So there's a lot of delaminated concrete that we can repair out there. It's just depending on what type of repair strategy you want. Do you want an overlay? Do you want a sealer? Are you thinking about putting some other type of product on top of your concrete? All that plays into the questions. Another thing that happens very commonly in concrete is crazing. I've heard people say that crazing is a finishing issue. It means that you've over-troweled the surface. I would disagree. I think the most common reason for crazing is that you have rapid surface evaporation of the mortar. And so what it really is a problem of is what George talked about last week. It's a curing issue. You did not use any initial curing. Same issue we can get with plastic shrinkage cracking. So you often can see crazing and plastic shrinkage cracking in the same slab. This can happen in vertical concrete and in horizontal concrete, and you have to have good eyesight, which mine is changing depending on distance. But without my glasses on, I probably don't see a lot of crazed concrete, but put them on and there they are, especially after it's going to soak into the surface cracks. These are just at the surface, so it's a fine network, typically tight cracks. So the question is this a blemish? In Florida, they pay money to have concrete look like this, but in the Midwest, our issue really is durability. Do we want scale resistance for freeze-thaw environments? So when you have a crazed surface, you have a network that's already prone to allow salt to soak into that cracked network. So what most repair strategists would encourage is for you to seal the surface. If you seal it, then you're going to slow the ingress of that salt attack and further scale and other issues. I'm in agreement with that strategy with one exception, and that is that it's going to make it show up more. So if it's an owner that doesn't have worries about scale resistance, depending on where this crazing has occurred, sealing it is going to highlight it. Unless you're putting an overlay down, which I don't think crazing needs an overlay. It's just about aesthetics and what everyone is okay with. There is other forms of scaling that can occur that are durability issues. You may not even see it well in this photo, although it is an excellent photo of it. At the tip of the pen, you might see some fine hairline cracks. The reason these cracks occurred in this picture, which comes from the Federal Highway, is due to the sand being chemically reactive with high alkalis. So this is ASR, this is alkali silica reactivity in the sand. Is this a problem? Well, it sounds interesting. It actually can be. It depends on how much sand is in your mixture and how reactive that sand is. And some sand is very reactive. So it could structurally change the concrete. It could cause map cracking to open up. It could cause volume changes in your concrete. This can happen in interior concrete and exterior concrete. The alkalis come naturally in the other concrete materials such as cement, cementitious ingredients. It could be in the water. It may be in the aggregates as well, depending on if they're recycled aggregates. And then the silica is what's naturally occurring in certain aggregates that breaks down under the combination of the two. So if you're worried about ASR, first of all, you should know your aggregates. Those should be pre-qualified through history as well as lots of testing that we have standards on. ACI 301's specification for concrete construction gives you guidance on how to design your mixtures for resistance to ASR, and it's there are some prescriptive, but it's really about knowing your rock and knowing what you're dealing with, and that includes on the fine aggregate side as well. Now, once you have it, what do you do? Well, ASR cannot occur without three things: reactive rock, well, okay, four things: reactive rock and alkalis, temperature, and moisture. So if you can't control the temperature because of swings in your exterior concrete, if it's an interior concrete, maybe you can control the temperature, but if it gets hotter, ASR is more likely to occur. And then the moisture, if you can control that, that's great. A lot of people think they are controlling moisture on interior concrete, so a column, yes. But on a floor, are you mopping it? Is there any other way they're getting moisture from a subgrade? Is there a bath sink underneath it that is allowing a lot of moisture? So these things have to be determined. And then what you might need to do is allow for expansion, depending, that concrete can remain in service for many years depending on what it is. So there's a lot of information out there. I encourage you to know ACI 301, but also to know ASTM C 1778, which is the specification for mitigation of alkali silica reactivity. Again, with crazing, you're not going to see it unless you have, so if you're out there in the field, well, maybe some of you have better eyesight than me, but if you're out there in the field, one thing you can do to show it, if you're having need for photos, is to spray some isopropyl alcohol on the surface before you take a photo, or if it's rained, go out that day and inspect concrete. You're going to see a lot more on a rainy day than you would on a nice, beautiful sunny day. This is an example of concrete under a microscope. Ignore the squiggle up in the screen, although they're identifying a certain piece of aggregate. But instead of this being crazing, what you see is that the cracks have slightly opened up into like a V notch. And what that means is that the concrete is now checked, is a term we use. It's more common in the paving industry, but checking, to me, again, is a bigger issue because this could imply more of a durability issue for scale. This means it's opened up, it's going to allow things in. So that's my only concern with crazing as well, is would it open up? And it just depends on how badly it's crazed, what type of service quality you had to begin with, and what was the mix design, what was the water cement ratio. Because a lot of times crazing happens on high quality concrete that you didn't do proper initial curing on. Initial curing can be fog spraying, evaporation retardants, wind breaks, all those things that were talked about earlier. Another issue with our surfaces are pop-outs. Pop-outs imply that the aggregate has ruptured in the concrete. And you see that in this classic photo where the rock here has broken apart due to expansion and basically thrown itself from the surface of the concrete. This can happen in vertical concrete and horizontal concrete, and it's usually due to freeze thaw, but it can be due to certain types of aggregate that just expand and rupture under moisture and temperature. So it's not always low temperature freeze thaw issues. This is one of the most common distresses we have in the Midwest. This rock here in this picture happens to be chert. It's a low density aggregate with a specific gravity less than 2.4. Is it allowed in concrete? Sure. And I'm not saying that in a negative way. We allow a lot of things in concrete. The specification for aggregates, ASTM C33, allows up to a certain percentage of chert, even in chert free, which is, there's no such thing, but it would be 0.5. To limit these materials is ideal. And of course, I didn't want chert in my driveway, but I walk down our streets and I see it everywhere. Here's one thing you can do. You can downsize your top size of your aggregate for these when you have these concerns. And that means that you're lowering the pressure buildup by having lower size, top size aggregate. But while you do that, you're changing the mixture. You're then upping the paste content, which may or may not be ideal for you. And it then changes your thermal control. It changes your shrinkage. It changes all sorts of things in your design. But there are things we can do to minimize pop-outs. And it really is about your surface finish. Doing something like an exposed aggregate finish definitely helps you with that, but it might not be ideal for all structures. So pop-outs are a nemesis in our industry. What can you do for them? You can mostly ignore them. However, it's kind of like not having a perfect face. Every once in a while we have a blemish every now and then. It's not really a durability issue on its own, but it's unsightly. So for architectural purposes, if this is something an owner doesn't like, they might want you to patch it. I can show you lots of examples of pop-outs that have been patched that look worse patched than they did as an original pop-out. But if a driveway truly has a ton of pop-outs, it also might have been due to their water cement ratio. You know, if you're allowing moisture in and to get to that rock, then it is about having a higher water cement ratio, a higher permeability, allowing the environment in, and not having freeze thaw resistance. So that's something to consider. So pop-outs can be better designed for by minimizing your top size of aggregate and controlling your water cement ratio. But you can get pop-outs in other types of aggregate as well. There are pop-outs in fine aggregate that can form due to that ASR topic we talked about. So this is rupturing of the fine particles of aggregate on the surface. This issue is a durability issue because it's showing a chemical reaction occurring interior of concrete, and it may or may not need some sort of relief joint. It might need a sealer. It depends on what the surface is. Scaling is a form of pop-out. And this is really a term that we use as mortar flaking. So this means instead of the aggregate popping out, it's a pop off. It comes off of the surface of the aggregate. And another term, a better term, is flaking. So it's maybe kind of difficult to see in this photo all these little pock marks, but in this next one, you have a side view under a microscope and you see a close-up of the piece of aggregate, and you can see that just the exterior paste, that top 1/8 inch, is peeling off. The reasons for mortar flaking, there's a variety of them. It could be due to blessing the surface, being a very popular reason for it. Not as common anymore, but say you had a high bleed on the surface, someone might be sprinkling cement on the surface to soak up that bleed water and then finishing it in. That could be a high sign for mortar flaking. Why anyone would, but they might purposefully sprinkle salt on the surface of fresh concrete because they like the look of the pock marks. I know Disney likes a little aesthetic texture to their concrete, and they've done that in the past. It to me is not an issue on its own. However, if it is initial scale, which is what I'm looking at right here, then I'm worried for your freeze thaw durability of that surface. It just depends on what surface it's in. If it's in a marine environment, it could be due to salt water as well. But in Ohio, I think you guys are safe. But you definitely see it in a higher end of what we call scaling. So in this example, you see what one might call a surface delamination, but it's that scale of the surface due to freeze thaw and exposure to de-icer salts. You can get minimum scale or you can get very severe scale. And what we need to do is design our concrete to be scale resistant. We need a maximum water cement ratio of 0.45, and we need a minimum strength. Powers from PCA did a lot of work on this and says it's 4,000. The codes now say it's 5,000 for exposure to de-icer salts, and they're just trying to give you less confusion by equating strength to water cement ratio, which is impossible to do unless you're the mix designer. So I care way more about your water cement ratio, and anytime you're designing in a de-icer climate, your water cement ratio should be less than 0.45, and if there's reinforcing steel, then it really needs to be less than 0.4 for corrosion resistance. Scale is very common in our industry, and it's something that we can design our concrete to a higher bar. And again, I did mention that we get scale in marine environments. We also get scale on vertical concrete due to snow plows and cars driving past a bridge abutment, where you can get the salt spray in that manner as well. What you do to prevent scale is sealing the surface and designing your concrete to a higher bar. If you already have scaling, it's just a choice if you want that overlay. Next subject is spalling. Spalling means that something came off your concrete as a fracture. So typically that means you have some interior cracking that has worked its way to the surface. So the definition of smalling by our industry is pressure buildup. It's usually due to expansion within. There are some circumstances that are exterior spalls. The most common reason for spalling is corrosion of reinforcing steel within concrete. Another reason would be freeze-thaw distress. Another reason would be alkali silica reactivity, and there are many other things that can cause interior spalling. You can usually get spalling with a combination of issues. What we have here is a flagpole that's showing you some galvanic corrosion. You got an aluminum pole in contact with regular steel. That's going to cause galvanic corrosion, and you can see some of the corrosion in the reinforcement in the bottom section. And you see a large chunks of concrete have spalled off here. Now, that's my initial diagnosis when I look at this photo, but I actually know this photo as a freeze-thaw distress and spall. If I also looked at this photo in, say, a parking lot at Walmart or Target, I would think maybe a car hit it. So we don't always know why something's spalled, but obviously this concrete needs some love and repair to keep it in service without having that flagpole tip over. We also can get spalls from exterior, not just trucks hitting things, but trucks overloading things. So whether it's a forklift or other thing, you can get what we call joint spalls and corner spalls of slabs, which is a shame because we can design to a higher end. And it's very important that we end joint our structures and that we, when necessary, make sure that those joints are properly spaced so that they can give the ride quality and you want to transfer that load properly. So load transfer is very important to us. What would I do with these spalls? I would do patch repairs. So on this edge joint, we'd be removing the material and making sure it's a proper edge if necessary for that structure. If it's a driveway, you might live with it. But if it's a interior industrial floor slab, you're gonna fix that. But you want to fix it with high quality, and you might even be reinforcing that edge, whether it's a steel plate or rubber plate. There's different things you can use for load transfer. Other spalls, we're talking patch repairs. So this one I'd probably rebuild because it's a small section. But in this example and others that I'll show you in a couple slides, if you have a large enough section, you might be shoring that structure and removing a section of concrete and doing a full patch repair with forms. Depends on the structure, as I said. I mentioned blisters earlier. This is an example of what a blister would do on the surface of formed concrete. We call these bug holes. Whether there's bugs in them or not is very rare. It's usually just trapped air. And those cavities are small and typically form while you're placing your concrete and it's being consolidated. The bleed water is trying to come to the surface in a vertical formwork as well, but how it does it, especially in a taller structure, 10 foot, 20 foot, it goes to the sides and then tries to come to the top. And depending on its effectiveness of consolidation and its bleed rate, it may get trapped at the surface. And it depends on how much bleed you have and how much air you have in that concrete. There's two types of air. You've got your entrained air that's going to hopefully be thoroughly mixed and homogeneous in that mixture and properly spaced apart. And then we have what we call entrapped air, that's your natural air from folding, that is going to need to be consolidated out. And this is what you're trying to do here. And if you don't do it for a proper amount of time, it can get stuck on the sides of the forms. And it may get stuck on the sides of the forms due to the form finish. Some forms have wax as a form release, and that can actually be a surfactant that causes an attraction. And so you can get air being attracted to the edge of a form, which can cause this. Is it a defect? I know it depends, but I'm going to give you my personal opinion. I find bug holes aesthetically pleasing. I think the industrial look is fabulous. The only time I would be concerned about bug holes is if you had, say, pre-stressed concrete with a cover of only 1/4 or 1/2 inch being allowed, then of course I'm concerned about the surface quality. So in pre-stressed, precast concrete, bug holes are usually part of their specification for making sure you don't have them. They'll use products such as self-consolidating concrete to overcome bug holes, but you can change up your mix too. Look at your air content you're generating, look at your form release agents, And then when necessary, yes, you can parge your surface. If it's a thing that needs higher impermeability, then you might need to patch your bug holes. Specifications should list their requirements for repair and aesthetics within them. That might involve a mock-up, so we all have the same expectations. Hopefully that makes sense to everyone. Like I said, I'm not necessarily saying this is a beautiful wall, it's a water treatment, but I actually like the look of this. And on a raw exterior hotel, I would not have a problem with that. I'd be more concerned about what their form finish was, if they had any fins, and what they had left for form ties as to how that looks than a bug hole or 2 or 20. But speaking of aesthetics, another thing that can happen is cold joints in concrete. You can get at times when placing more than one truck, joints that form due to one section of concrete hardening before the other is placed. Now, I don't think you can see my mouse, but you can see lines that are vertical, and those are the form work. Don't look at those. But if you go about halfway down the structure, you're going to start to see a diagonal line that is also slightly on a slant here that should have been more horizontal. So it's also proving that they didn't place their truck very uniformly. But what happened is these are 2 different trucks, and you can definitely tell that. Maybe it's just because one has more water in it or has a different material in it, but that shouldn't happen either. They should be consistent. So what we're really looking for is a bond. So my question to you is it a cold joint or is it a pour line? A pour line means it bonded. A cold joint means that you could actually have a non-monolithic structure depending on the amount of reinforcement and the bond. So that could be an issue for wind. It could be an issue for moisture ingress and all sorts of things. So it can be something that you actually have to determine, like in this example here where you can see the pour line as well. So what you need to do is actually not just walk up to it and look at it with a microscope. That's not going to tell you anything. What you need to do is core through it. So if you take cores through a cold joint, or a pour line, you should say, until you know it's a cold joint, you then test it in compression, and that gives you its shear strength at that bond. And so depending on the age of the concrete and the strength needed for bond between layers to make it a monolithic structure, and depending on the amount of reinforcement in it, then the engineer can decide what that minimum bond strength might be. They might ask for 1,000 PSI, they might ask for 2,000 PSI, it depends on the structure. But that's how you would fix that. And then if you needed a better bond, you don't need to tear down the structure, you inject that cold joint with a some sort of crack repair. Typically an epoxy or cementitious grout. If it's just a pour line, it's just unsightly. So it's up to you if you want to paint that structure or not. And that it should be already in the specification as to what was expected. Speaking of expectations, color tends to be an expectation, and I love all shades of gray. They just should probably pick only one for one driveway or structure. And that can be due to timing of formwork removal. It can be due to exposure to rain. It can be due to different materials being used throughout the structures. But one of the most popular things that happens, and George may have talked about this during the curing talk last week, is what we call greenhouse effect when you're using plastic sheeting on surfaces of concrete. So this is an excellent example of that, where you get dark and light spotted concrete, mottled spotted concrete. I just made up a new word, spotted. But it's blotched. It's not perfect. One of my best examples of discoloration of concrete was when they were building Miller Park. This nasal accent is Wisconsin. It was brand new, open, back when we could go to the ball field, and I was standing outside of it, and everyone else is rooting for the Brewers, and I'm looking at the best example of greenhouse with use of calcium chloride, where they had such a mottled surface. And this is so long ago, it was the 90s, that I didn't even have a camera on me, let alone a smartphone with a camera in it. So the next time I went back, because I lived in Illinois, next time I went back to the stadium was about 3 months later for games. So this would have been early spring versus midsummer. And because of heat and because of oxidation, it was gone. So it's not always something that lasts. It depends on the structure itself and why it occurred. But it is something that discoloration can be a problem in concrete. Of course, we want the color of concrete that we asked for, but sometimes it's something that's temporary. This is not temporary. Don't look at the streaks of the car tracks, but look at the fact that the bottom half is darker than the top half. This is going to last in a structure, and it may or may not be acceptable. What probably happened here is that they waited to place the second batch, and they wanted to do the final finishing operations at the same time. So they added some higher amount of calcium chloride to the second batch. Calcium chloride is allowed on non-reinforced plain concrete. However, just know that if you only add it to one half of your mixture or your design, I mean, because it's two different trucks, then it's going to change the color. So that's an issue. What could have happened also is higher water content. If it's fresher concrete, the higher water content would be the second batch, but in older concrete, that would mean it's the first batch. It might be that one mix had fly ash in it and the other one didn't, so it changed the color of gray that comes out. There's so many reasons for discoloration, which unfortunately, we maybe don't raise the bar high enough for all residential concrete, but I would like to say that in most commercial concrete, the standards are pretty high in the default specs for aesthetics. And if it is architectural concrete, the standards are even higher, especially when it comes to material selection and formwork removal and such. And that's why mock-ups matter. Don't expect a mock-up on a driveway, but you might want to see their work elsewhere and be aware of this type of issue. Another thing that can cause staining is in the aggregate itself. The source of aggregate may have. This is actually a Frank-Lloyd-Wright structure that has iron ore in the aggregate. So this is something you'd want to do something about if it's something that you need to repair. And you can do that with certain repair materials that will remove the stain. Should you tell the owner it's going to come back? Absolutely. But you can do things to prevent the timing on it coming back. And then, of course, we can get staining from many other exposures to corrosion and such. In this example, there's many more things going on than staining. That's corrosion of reinforcement. There's some mat cracking there to reactive aggregate. I only know all this not by looking at a photograph, but because I know that bridge. So I know that bridge has had ASR and, of course, freeze thaw and corrosion. But just looking at it, I would want you to tell me that you see staining. You might want to guess it's rust. You see a white deposit that may or may not be efflorescence, may or may not be ASR gel. You see mat cracking, and then you take lots of photos that tell the story better than your words do. Speaking of efflorescence means that moisture ingress has gone through the concrete and brought salts to the surface, so you get a white deposit. Efflorescence on its own is not a blemish. Unfortunately, though, it usually comes with many other issues such as spalling and corrosion, and that means that you have a moisture problem that could be a durability problem. So that's something to consider. And last but not least of topics before I open it up to questions is honeycombing. It sounds so simple. It's just a failure of proper consolidation, and so you get some loss of paste around aggregates. What's the good news here? You can see it. So if you can see it, you can repair it. What's the bad news? Now I question the rest of the structure. I want to know how the interior of that concrete is. Uniformity matters, consolidation matters, but I wouldn't only blame the contractor here. This could have been a spec that restricted slump and flowability and then caused this to happen. Maybe it was the method of construction. Maybe there's another way, pumping or using proper ports that could have gotten this to be a more cohesive structure. We also can get places that the formwork leaks, and you can get sand streaking, and you can get areas where paste leaves the structure. There's bigger issues in this one. They obviously left it in service. This is actually a bridge abutment wall, so it's been in service for many years. And you also see honeycombing often wherever there's a window or a pipe or anything that could cause any type of restraint of getting the concrete to flow readily around. This is where SCC would be a great idea, whether or not it's necessary. So what you would do here is you would patch it, and that would mean not just parging and slapping concrete into that hole, but actually cutting out the deterioration and making sure you have a uniform shape so that you don't get shrinkage away as you're patching. And there's great guidance for you in the International Concrete Repair Institute's patching guides and in that Corps' manual of repair, which I highly encourage you to get. And then if you do repair it, just remember it might not be pretty after you've fixed it. So if you want durability, you get one thing. If you want aesthetics, you have to pay for that as well. And unfortunately, sometimes in our industry, we don't do everything perfectly. And so we can tell this is a Monday job because it's a soda. If it was a Friday job, it might have been a different beverage. But it is unfortunate that anyone would take concrete and use it as a garbage can. Those stories usually come to the surface. So we expect higher work. We know we can get it out of people, and we know we can ask for it. So in closing, the takeaway from this is to relate all of these symptoms to the causes of the distress so that you can determine if you need to repair it, if it's proper to repair it, and what your expectations of service life are. So with that, I'd like to thank you for your time. I'm going to be sharing my contact information with you all, but I'd like to open it up for any questions.
Michelle, thank you. That was an excellent presentation. Really appreciate it. We do have one question here. How often do you reseal the surface of your driveway? Mr. James Leahy.
That's a great question. Sealing is a debated topic, and there's different theories. It depends on the type of sealer you're using. There's sealers that are surface sealers. There's sealers that do go into maybe 1 inch, 2 inch of your, and so it depends on what type, if it's a penetrating sealer or a surface. Most of them, especially on the homeowner side, they last about 3 to 5 years. So you have to look at the manufacturer's recommendations and reapply. There are a few of the higher end sealers that are really meant to be moisture barriers, but really have still have some penetration of the outside environment. They might be used on parking garages and stuff. So there are fewer higher end ones that are thicker, need several applications for the initial application that might last up to 10 years. But there's, again, a great guidance out there on sealers for you through the International Concrete Repair Institute.
Michelle, kind of a follow-up on that. I got a couple questions text to me, and one of them was preferred sealers. Can you expand a little bit maybe on what you would consider, or you want to stay away from that completely?
I would prefer not to mention one brand over another. We did use a penetrating sealer on my own home, and I like the idea of them. How well they work versus application depends on who's applying them, how clean your surface is, how much you're actually applying, and the timing, because some of them dry very quickly, and then once they're dry, you're supposed to be putting 2 layers, usually cross from each other, and depending on how you roll them and timing, that could be an issue. So it's who's performing the work and what product it is. Both those things matter very much. But there's great products out there. So I would recommend they go to ICRI, and there is also a sealer association for concrete as well.
Okay. Another question relates back to when you talked about the sidewalk along the building and expansion material versus isolation material. How do you know when it's best to use expansion, at what distances? Can you expand on that? That should be part of,
that should actually be part of the design. So concrete is designed structurally, whether it's a pavement or it's a building, and vertical walls expand as well and should have some sort of expansion joint built into it or designed for that movement throughout the structure, or you're going to get vertical cracks in it. Sometimes they add a lot of extra steel to hold things together, but on a pavement, no matter the amount, there is the concept of continuous reinforcement, but then you're going to get a lot of cracks shortly together, and it's just about whether or not the amount of steel can handle expansion and contraction. What's typically still recommended, and you'll see it in pavements and in bridge decks, is about every 100 feet, and depending on the thickness, it might be every 50 feet, you're going to see a wider expansion joint. What we did for a personal design, when it's not an engineer doing the design, say about 100-foot length of a driveway, put a proper isolation joint between the sidewalk and the end of the driveway that is compressible, so it has the ability to expand and contract, and it's moisture proof too. So there's a difference, especially in residential construction, between using that felt type, or some people like to even put wood in, and they like the look of it and consider the wood to be compressible and be part of an isolation joint. It is an isolation joint from the restraint of bond against exterior concrete, but it's not an expansion joint. It doesn't give you the same movement that a proper commercial material would do. So isolation joint material can be used to help you with a residential type application, and then on the commercial end, there's much higher end material available.
So further clarification on that, would you ever replace what is typically an isolation joint with expansion material to kind of serve both purposes?
Yeah, it would depend on what you were using. I think it would depend on, like, if you saw felt somewhere and felt that I don't mean to use that word two different ways. If you saw a material that wasn't as compressible in a location and you wanted to repair that, it might be appropriate, if you saw movement or debris buildup or anything, for you to clean out an area, whether that meant routing it and putting a compressible foam in. I will admit, I did not seal my joints. I sealed the driveway, and I have continuous reinforcement. And the reason that I didn't seal it is because my theory is my driveway will last longer than me. Maybe I'm not doing a service to the next homeowner. So it depends on how long you want that product to remain in service, if there's going to be, any corrosion issues. So the sealing of joints versus getting really high-end joint material. So I have isolation joint material in all my control joints and such, but I don't, any of my open, what am I trying to say? Any of my open contraction joints aren't sealed. So you just have to design properly. A lot of people like joint filler. They feel very strongly on, making sure that you get proper load transfer, that you're keeping a clean joint and all of that. I think it just depends on what you have for drainage and what you have for maintenance. I have a wonderful partner that cleans out every single joint and blows them out. And if you have that, then you have a good maintenance plan. But a lot of people let joints fill with debris and don't keep, daisies are growing through them, and that's an issue. So.
Okay, another question just came in. Do you have a favorite go-to technical document when a residential driveway owner is upset about minor imperfections?
I do, but I'm biased. It would be mine, and I'm going to share it with you guys. So it's a slightly older document, IS 177, Effects of Concrete Surface Defects. Everything that we've talked about today is in writing. I have cleaned up the chapter for our next edition of PCA's Design and Control, which will be coming out in 2021. And so it's a manual that would not be for a homeowner, but this is a nice information sheet. It's about 20 pages long, and you can just, if you want, you can just print off the paragraph that has to do with them. And that's really what my job at PCA is to be, not only make sure standards and our industry is doing their job well, it's to make sure that concrete turns out. So if you're having any issues, we all know how to do it right. And so having it in writing really backs up how to calm a homeowner, but also how to make sure that you're designing to the right bar.
Okay. Well, Michelle, we don't have any other questions at this point. So thank you. You did an exceptional job on a very tricky topic. And we appreciate your time and coming on.
Well, thank you for the invitation. And like I said, I'll send that information out to you. And I understand that the program itself was recorded. So yes. Appreciate the invite.
And for the group, I just want to remind you that next Thursday, we're going to have our first shot at 2 speakers. Mr. Dan King with Perrin Concrete is going to talk about the perfect concrete parking lot. And also Dan Miller with ODOT is going to kind of give an update on any concrete specifications. So look forward to seeing you all back again next week at 1:30 on Thursday. Thank you.